Hello everyone, my name is Nick, and I'll be doing a video presentation on the topic of distribution and univariate data. So first, let us define what distribution is. A data distribution is a function or a listing which shows all the possible values or intervals of the data. It also, and this is important, tells you how often each value occurs. Often, the data in a distribution will be ordered from smallest to largest, and graphs and charts allow you to easily see both the values and the frequency with which they appear. So now let's move on to the measures of central tendency. The measures of central tendency indicate where most values in a distribution fall and are also referred to as the central location of a distribution. You can think of it as the tendency of data to cluster around a middle value. In statistics, the three most common measures of central tendency are the mean, median, and mode. The mean. The mean is the average of the numbers. It is easy to calculate. You just add up all the numbers or set of terms, then divide them by how many numbers there are. In other words, the mean, m, is the sum of the terms divided by the number of terms. The median. The median is the middle value in the list of numbers. To find the median, your numbers have to be listed in numerical order from smallest to largest, so you may have to rewrite your list before you can find the median. If there is an odd number of observations, the median is the middle value. If there is an even number of observations, the median is the average of the two middle values. The mode. The mode of a dataset is the number that occurs most frequently in the set. To easily find the mode, put the numbers in order from least to greatest and count how many times each number occurs. If no number in the list is repeated, then there is no mode for the list. The number that occurs the most is the mode. And now we'll be learning about the measures of dispersion. In statistics, dispersion, also called variability, scatter, or spread, is the extent to which a distribution is stretched or squeezed. Common examples of measures of statistical dispersion are the range, standard deviation, and variance. The range. Range is the most common and easily understandable measure of dispersion. It is the difference between two extreme observations of the dataset. If x maximum and x minimum are the two extreme observations, then range is equals to x max minus x min. The standard deviation. Standard deviation is the positive square root of the arithmetic mean of the squares of the deviations of the given values from their arithmetic mean. It is denoted by a Greek letter sigma. It is also referred to as root mean or square deviation. The standard deviation is given as the population of standard deviation equals the square root of the summation of each value from the population minus the population mean squared over the size of the population. The variance. In probability theory and statistics, variance is the expectation of the squared deviation of a random variable from its mean. Informally, it measures how far a set of numbers are spread out from their average value. To calculate variance, start by calculating the mean or average of your sample. Then, subtract the mean from each data point and square the differences. Next, add up all the square differences. Finally, divide the sum by n-1, where n equals the total of number of data points in your sample. And now we are finally moving on to discuss univariate data. So univariate data is a collection of information characterized by or depending on only one random variable. When we conduct a study that looks at only one variable, we say that we are working with univariate data. For example, suppose that we conducted a survey to estimate the average weight of high school students. Since we are only working with one variable, weight, we would be working with univariate data. Another example is conducting a survey of what the typical net worth of an American family is. We are interested in how responses vary from person to person when asked about their family's net worth. We would want to summarize the data using statistics that represent the majority of people in the population for whom the question is being asked. Now let's discuss the two reasons when and why we use univariate data. First reason is to answer a research question that calls for a descriptive study on how one characteristic or attribute varies. The second one is to examine how each characteristic or attribute varies before including two variables in a study using bivariate data or more than two variables in a study using multivariate data. Now, before diving into the basic descriptive tools for univariate analysis, I will just quickly explain what univariate analysis is. So the analysis of univariate data is thus the simplest form of analysis since the information deals with only one quantity that changes. It does not deal with causes or relationships, and the main purpose of the analysis is to describe the data and find patterns that exist within it. Here is a simple example of this. So as you can see in the table, it only indicates the one variable, and that is the height of 8 different people. So now that you have a basic idea, let's now move on to the basic descriptive tools for univariate analysis. First up are proportions, percentages, and ratios. Proportions are the number of cases belonging to a particular category divided by the total number of cases. The sum of the proportions of all the categories will always equal to 1. Percentages are proportions multiplied by 100. And ratios are another way of expressing the different numbers studying science and arts or social science subjects. Here are some examples. Next are frequency tables. The frequency table or frequency distribution is commonly used to provide a snapshot of a variable. It is commonly made up of 4 columns: the values or categories of the variables, the number of cases, the percentage of cases, and the cumulative percentage of cases. Here is one example. And now for the last one, the bar charts, pie charts, and line graphs. Bar charts or pie charts are good for showing the variation of the percentage of cases for each value of a variable. The pie chart compares parts to the whole, and the bar chart compares categories or values. The line graph is good for longitudinal data that reveals trends over time. And here are some examples. So we are now at the end of the presentation. Thank you all for watching and stay safe.